Okay, hi everyone. Today we are going to look at LCM, which is lowest common multiple. Previously we looked at HCF, which is our highest common factor, right? And based on that, we have discovered, I think, the three different ways, okay, to find the HCF of two or three numbers. We are going to use roughly the same methods, right, to find the LCM, lowest common multiple of the two to three numbers as well, right? So here, without further ado, let us refer to the textbook in page 20 and practice now 12. Okay, we are going to start to find the LCM of 24 and 90. Okay, so let us write this down. So in this section, oops, in this section we'll be finding our LCM, right? Let's write this down in our notebook, yeah? Lowest common multiple. Okay? Okay, now practice now 12, page 20. Okay, so make sure you are writing this down, yeah? Okay, because this is as if we are having a lesson in class, okay? So we uh, don't need to redo this in class, so make sure you really write this down. All right. Okay, all right. So the textbook question is here, okay, on your upper right. So we are finding the LCM of two numbers, 24 and 90. Now, let's take a look at the basic concept of what's going on, like the other time. So the basic concept is we need to list down, right, by listing. Okay, let's say if we have, let's look at the multiple of 24. Alright, so we list down 1 times 24 will be 24, 2 times 24, 48, 3 times 24, 72, right? And then we have 96, we have 120, we have 144, we have 168, and so on. Now, we are going to go on to, in order to save time, right? I'm going to go on all the way to 336, 360, 384, 408, and so on and so forth. All right. So I'm actually, yeah, because the number is actually quite big. So I'm actually, in the favor of time, we don't list them down. Okay. But the concept is that we still need to list them down. Okay. Next, let's look at multiples of 90. Alright, so 1 times 90, we get 90. 2 times 90, 180. The next one, 3 times 90, 4 times 90, and 5 times 90, and so on and so forth. Alright, now I think you can see that these are our multiples of 24 and these are our multiples of 90. So which number is a common multiple of 90? So you can see that actually you have your 360 over here, you have your 360 over there. Alright, now if you continue on the process, right, if you continue to list down the numbers, okay, I will do this for 90. So let's say if you continue on, for after 450 you have 540, 630, 720, 810, and so on and so forth. Now for the 24, at some point of time you arrive at 720, 744 as well. Alright, so the thing is you have your next common multiple of 720. Okay, but the thing is we are now looking for the lowest common multiple. So the smallest common multiple between 24 and 90 is actually 360. So the LCM of 24 and 90 is equals to 360. Okay, so this one will be the basic concept. Now, as you can already see from this number 24, if you were to list them down, it's going to take very long and it's going to take forever, right? So we will use the two methods that we've learned earlier, and we're going to use them to find, right? The two methods that we've learned earlier, we're going to use them to find out the LCM more efficiently, right? So let's take a look at the method 1 over here. Okay, and previously our method 1 was prime factorization. Alright, so we have 24 and 90 as well. Yeah, we're still at question 1. Okay, so 24 and 90. So let's take a look at 24. We do the prime factorization. Divide by 2 to get 12. Divide by 2 to get 6. Divide by 2 again to get 3. Divide by 3 to get my 1. Okay, same thing for 90. I'm going to divide by 2 to get 45. I can't divide by 2, so I divide by 3 to get 15. Divide by 3 to get 5. Divide by 5 to get my 1. Okay, so these are my prime factorization of 24 and 90. So 24. Now let me list them down separately. Yeah. So I have 2 times 2 times 2 times 3. Then for the 90, I have a 2. I don't have 2's anymore, so I'm going to just write the 3 behind and line them up nicely. Okay, so this thing is that I really need to line them up nicely. Okay, next, let's take a look at the LCM of these three numbers. Now, in order to find the LCM, we just need to take all the factors that we can get from 24 and 90. So the unique factors over here, right, from each of these numbers, and for the common factors, we just only count once. Okay, for the common factors, we will only count once, but the other factors we'll need to take down. Other unique factors, we need to take them down. Okay, so we will need to take 2 times 2 times 2 times 3 times 3 times 3. So this round we need to line them up properly as well. Okay, and you can find that actually we have 360. Right? If you were to take 24 times 90 yourself, you may run into the trouble of getting a larger common multiple. Okay, so it will not be the smallest common multiple. So we can't just times 24 and 90 together. We need to look at what are the common oh sorry, it's not 3. I have one mistake over here. This one is 5. Okay, now so the thing is we cannot take the just multiplying 24 times 90. We have to look at what are the common factors so that we don't double count those common factors. Right? So this is the prime factorization method. Now, as mentioned, there will be an easier way to write this, right? So a neater or more efficient way to write this, okay, would be to list them down in the index notation. So 24 we found earlier was 2 cubed times 3. 90 we found earlier was 2 times 3 square times 5. Okay, as you can see from this one over here. Now, so when we do this, right, when we do this, now 5 also is 5 to the power of 1. Okay, if you don't see the power. So over here, what we are going to do is we're going to take the highest power. Right, we're going to take the highest power. So what is the LCM of these two numbers? So the high one with the highest power, 2 cube or 2, we're going to take 2 cube. Between 3 and 3 square, we're going to take 3 square. And between nothing and 5 power 1, we're going to take 5. Okay. because as we have a 5, we will take that. So it's a bit different from HCF, right? For HCF, we'll take the lowest power. For LCM, we take the highest power. So we have 2 cube, 3 square, and a 5. So over here, we multiply to 360 with your calculator, right? As you can compare, we have a 2 cube, we have a 3 square, and we have a 5, right? So by writing down in index notation, it will be a bit more easier to look at. Okay, now so this is method 1. For method 2, okay, method 2, okay, it's same question, but for method 2, we will look at the ladder method. Right, so let's look at ladder method. We have 24 and 90 earlier, okay, and we can just put them in just one ladder. And let us divide by common factors. First, okay, 24 and 90, let's divide by 2. So 24 divided by 2 is 12, 90 divided by 2 is 45. And we cannot divide by 2 anymore, so we divide by 3. So 12 divided by 3, 45 divided by 3, right? And 4 and 15, we don't have any more common factors to divide by, right? We have to stop here. Alright, so how do we find the LCM? So for HCF, we take the common factors, right? For LCM, we will need to consider the unique factors as well. So we have our common factors and the unique factors. So we need to take all of them together. So think of it as taking an L. Okay, so for the LCM, it will be 2 times 3 times 4 times 15, and in the end of the day, you get your 360 as well. Okay, so this is for method 2, right? So if you have a ladder method, just take the L for LCM. But for HCF, remember, for HCF, you need to do it differently. Okay, remember, yeah? Now, let's move on to question 2. So we have explored the two efficient methods to find the LCM. Oh yes, method 2 is ladder method. So we have two efficient methods to find the LCM. Now, for question 2, right? Question 2, we move on to question 2. They gave us two numbers, and the two numbers, they've already listed down the prime factorization. So with this, we don't have to do the trouble of finding it one by one. We will just use this information straight away. So we have 120 equals to 2 cube times 3 times 5. 126, we have 2 times 3 squared. We don't have a 5, so we leave a gap, and we have a 7 over there. Alright? So because we are doing prime factorization method, for this LCM, we will need to take the highest power. So it's like the reverse here. So for the lowest common multiple, we take the highest power. Right? For the highest common factor, we take the lowest power. Okay? So between 2, which one do we take? We take 2 cube. Between 3 and 3 square, we will need to take 3 square. Between 5 and the empty gap, we will take 5 because it is a unique factor over here. Then between an empty gap and 7, we're going to get 7. Okay, so our LCM would be 2 cube times 3 square times 5 times 7. Okay, so when you multiply this together in calculator, you will get what's the number? 2520. Okay, so for question 2, they've already given us the prime factorization, so we might as well use it, right? So we might as well use it. Now let's push this a bit further. Right, let's push this a bit further. Let us now look at the next question on practice now 13, where we look for the LCM of 3 or more numbers. So let's look at practice now 13. Okay, practice now 13. We are in page 21. And now we are going to look for the LCM of 3 numbers 9, 30, and 108. Now technically we can list them out, but it's going to take us forever. So what we are going to do is to use the two methods, alright? We are going to use explore the two methods over here. So method 1, we'll be doing our prime factorization. Method 2, we'll be using the ladder. Okay, as usual. Alright, so for prime factorization, to save time, right, you can do the ladder on your own. Okay, you can do the ladder on your own on this side. But to save time, I'm just going to give you the prime factorization over here. So we have 9 is equals to something. We have 3 square over here. Leave a gap there. 30 is made up of 2 times 3 times 5. Alright? And for 108, the prime factorization would be 2 square times 3 cube. Right? So by right, you will need to do something like this, yeah? You need to do the divide by 2. Okay, you need to do this. Okay, and then you need to do that. Right? By right, you will need to do all this. But in the interest of time, we will I will just give you this prime factorization, okay, because we just need to look at the concept itself. So how do we find the LCM of these 3 numbers? We will just need to look at the highest power. Okay, we just need to take the highest power. So between these 3 numbers for the row of 2, which one has the highest power? 2 square. Between this column of 3 numbers, which one has the highest power? The 3 cube. And between this column of the empty gap and 5, we will take 5, okay? Because we will take all unique vectors. So, last but not least, let's list them down. We have 2 square times 3 cube times 5. Key this in your calculator, you're going to get 540. Okay, so one more time, we will be taking the highest power, and by taking the highest power, we will see that, you know, the LCM of these 3 numbers is 540. Imagine if you were to list them down, it will take a very long to go. Okay, now let's explore method 2. Okay, apologies. Now let's explore method 2. Okay, so method 2 will be looking at the ladder method. Okay, so for the ladder method, we're going to go and list down our 3 numbers over here, 9, 30, 108. Okay, the question is still there. And let us draw a long ladder. Okay, now let's divide the first one. So we divide by common factors, right? So we divide all 3 numbers with a common factors first. Alright, so which common factor can we divide by? We can divide all of them by 3. Okay, so 9 divided by 3 is 3, 30 divided by 3 is 10, 108 divided by 3 will give me a 36. Alright, so now we don't have any more common factors to divide by, right? So this is a more complex process. Right? No more common factors. So what do we do? Instead, we will continue to divide. No more common factors for all three of them. Okay, so what do we do next is we will divide by common factors, right? For instead of three of them, so we're going to continue with two of them, any two of them. So I'm going to start with 3 and 36 because I can divide 3 and 36 by a common factor, right? So I can divide this by 3, but now I'm only dividing by dividing 3 and 36. So I'm only dividing these two things. So 3 divided by 3 is 1. 36 divided by 3 would be 12. Okay. Now the next thing that I'm going to do is same thing. I cannot divide by divide by common factors for all three of them. I can only divide by common factors for only two of them. So the two that I'm going to refer to now is I'm going to divide by 10 and 12. No, divide 10 and 12. And I'm going to divide them by the common factor of 2. So I have 10 divided by 2 is 5. 12 divided by 2 is 6. Okay, at this stage, I don't have any more common factors between 3 of them and between 2 of them. Alright, so what I'm going to do is for LCM again, I'm going to take not just the common factors, I'm going to take the L over here. So I need to multiply by all the numbers that I have over here. So the LCM is equals to, along the L, 3 times 3 times 2 times 1 times 5 times 6. So this will give me 540, which is what you saw from the previous method. Okay. Alright, so this ends our video for the LCM. So I hope you've been writing down and copying down these notes, okay, into your workbook. And in school, we are going to push forwards to look at, to do some problems and to explore some problems involving HCF and LCM. Alright, that's all we have for today. Hope you have a nice day. Alright, bye bye.